What's going on, everyone? Welcome back. Patrick here, and in this video what we're going to talk about is patterns of distributions. And more specifically, when I say patterns, I'm going to talk about the symmetry of a distribution, and we've actually already briefly talked about symmetry in previous examples when I brought up skewness, when a distribution is skewed to the left or skewed to the right. And I'm actually going to be bringing back some of those examples to help me explain these concepts in a little bit more detail. So when we're talking about the symmetry of a distribution, there's basically three cases. Either the distribution is going to be skewed left, it's going to be skewed right, or it's going to be symmetric. And we'll go over all three of these subcases. And then also, when I'm talking about patterns of distributions, I want to talk about unimodal distributions versus bimodal. What those mean, what the differences are. And I'm going to be relating all these concepts to a stem plot, a histogram, and a density curve that we've covered in the previous videos. So the first case I want to go over is if a distribution is skewed left, and another way to say it is that it's negatively skewed. So both of these mean the same thing. So starting with a density curve, the way that it's going to look is that you're going to have this sort of peak on the right side. And then you're going to have this tail kind of extend out to the left or to the negative side. That's why it's called being skewed left. It's where that tail is extending out to. And so this is how a density curve looks like for a distribution that is skewed left. And to describe it in words, remember that this here, it's going to be the intervals of the quantitative variable that we're looking at. And so all of the lower values are going to be here, and all the higher values are going to be there. And so if you notice that there is, in this kind of distribution, a small number of low values, a small number of low values, because notice that that frequency on the y-axis here is really low. And then over here, notice that the bulk of the data is on that right side where all of the higher values are. And notice that if we pick like a point here, that frequency is way higher than here. And so there's a small number of low values, but there's going to be a large number of high values. So in words, that's what describes a distribution that is skewed left or negatively skewed. Now, the corresponding histogram and stem plot, the way it's going to look, let's start with the histogram, since it's going to be really similar to the density curve. The way the histogram is going to look is you're going to, again, have a large number of these high values. So the frequency is going to be higher on that right side. So it's going to look something like this. It doesn't have to exactly look like this, but it has this kind of, it has that kind of shape. So that's how a corresponding histogram would look. Very similar to the density curve. And then the corresponding stem plot, the way it's going to look, so if we have that line that splits up the stems and then the leaves, remember with a stem plot, the lower values are going to be up there, and then the higher values are going to be down here. And so for a distribution that's skewed left, we have a small number of low values, and so that number of observations here is going to be lower. And then as we go down the stem plot, should get higher and higher. We'll have just more leaves as we go down the stem plot. right? It looks something like that. Remember, if we take a stem plot and we rotate it, we should get the shape of the histogram. Notice if we take this and rotate it, it would be a very similar shape to this. And we went over an example in a previous video where the distribution was skewed to the left or negatively skewed. It was the number of people at a Starbucks. Number of people at Starbucks at 9 a.m. We went over that example in a previous video. And so what it showed us was that at 9 a.m., the frequency, the number of people at a Starbucks was higher. And that made sense because at 9 a.m. most people are going to get their coffee. However, if you wanted to make sure that that is the reason why, because of the time, what you can do is you could sample those same locations again at a less busy time. So let's say you sampled them at 2 p.m. or 3 p.m. What you would expect is the opposite effect. You'd expect the number of people to be at those locations to be lower. So you'd have more observations for that low frequency. But let's say that at that less busy time, you still got this distribution here. Then the time may not be the reason why those certain locations have more people. It could be because they're in a better location. There's just more traffic around in that area. It could also be there's better service, so more people enjoy going to that Starbucks there. There could be other details. There could be other stuff that we're missing. So sometimes when you're looking at a shape, it could tell you certain things that make sense, but sometimes it could point you to a different direction. And the point I'm just trying to make is that a certain shape of a distribution tells you where to focus your attention and really figure out why it's happening like that. The next case we'll deal with is if a distribution is skewed to the right or positively skewed. Both of them mean the same thing. And again, starting with a density curve, the way this kind of distribution would look is if we have a peak on this left side here and then that tail extends out to the right. Remember, the tail extending out, that's where it's going to be skewed. So notice that it's skewed right here. And if we were to describe this in words, remember, these are all the low values. These are all the high values. And then the y-axis is the frequency. And actually with a density curve, it's the relative frequency. But what this tells us is that there's going to be a large number of low values, right? Because all these low values, look at the frequency. There's a lot more of them. And then there's going to be a small number of high values. So we've got these high values here of a quantitative variable that we're looking at. And notice that that frequency is a lot lower at that point. So a large number of low values, a small number of high values describes a distribution that is skewed to the right. And the corresponding histogram, the way it looks is, again, that frequency for these low values here is going to be high. And then as those values get higher and higher, that frequency goes down. It's going to look something like that. And then the stem plot, the stem leaf plot, remember all the low values are up here and then all the high values are down here. And so there's going to be more observations for the lower values. And then as we get to the higher values, those observations are going to go down. Notice if we rotate this, we get that same shape as the histogram. Right? So density curve, histogram, stem leaf plot, that's how they look like if that distribution is positively skewed or skewed to the right. We went over an example with this with the weights of the tigers in Nepal, and we had a larger amount having a low weight, right? And then a smaller frequency of them having a higher weight. And then we started analyzing a little bit more. First thing we got to make sure is that all the tigers sampled were the same age or around the same age, because if they're not, then it might make sense that maybe you're looking at younger tigers that haven't fully grown yet. You're looking at more younger tigers and then a smaller number of older tigers. But if they are the same age and then this happens, then what's going on? Like, do these tigers just have an easier time finding food in their area? Maybe these tigers here, the area in which you sampled them, there's some human interference going on, which is kind of interrupting the ecosystem. So again, you could look at this shape and then dig in a little bit more, figure out why it's happening. Actually, a very popular real-life set of data that has a positively skewed distribution, or skewed to the right, is the average income. The average household income. Most household incomes are going to be around here. They're going to have these sort of lower kind of to average values, while you're going to have a few number of people that have an extremely high income. So millionaires, billionaires, etc., etc. You know, you heard that whole saying, the top 1%. This is why it is happening. So most people are going to be around here with their income, while a small number of people are going to have a very high income. So that is a popular real-life scenario of where a distribution is positively skewed. And then the final case is if a distribution is symmetric. And the way that's going to look is that that peak is not going to be on the left side or the right side. It's actually going to be right in the middle. Let's try to make this symmetric here. So notice that that peak is right in the middle. And so if you describe a symmetric distribution in words, it's going to have an equal amount of low and high values. So an equal amount on both sides. It's symmetric. The way the histogram is going to look is it's going to increase, maybe get to like there, and then it's going to decrease. Again, symmetric. And then the stem plot, that frequency is going to increase. It's going to be the highest in the middle, and then it's going to start to decrease again. So if we take this, if we flip it, we would get that kind of shape. So that is a symmetric distribution right there. So that peak is neither to the right like it is for a negatively skewed distribution. Remember, that peak is here. The peak isn't here. For a positively skewed distribution, it's right in the middle. Now, one thing I want to mention is notice that, I'm going to draw out these density curves again, that for all these density curves that I've drawn out, for a symmetric density curve, or if we have a positively or a skewed to the right distribution where that peak is here, or we have a negatively skewed distribution like that, skewed to the left, notice that each of these, they have a single peak. Right? Notice we didn't have like multiple peaks at all. All of them had a single peak. And whenever you see a distribution like that, it's called a Uni-Modal distribution. basically means that there is one peak in the distribution, and that peak represents the mode, which is something we're going to talk about in future videos more when we talk about measures of central tendency. But the mode is basically a value that's happening that has the highest frequency in a set of observations. So notice that there's only one mode that has that high frequency in all of these, right? The value is changing, whether it's a low value or a high value or the value in the middle, but nevertheless, there is just one peak. There is just one value that has that highest frequency. So that's what a unimodal distribution looks like. Could be any of these three. There's also something called a bimodal distribution, and that's when there are two peaks. So we haven't covered that yet. Two peaks or two modes. And so the way that would look, let me erase this one here, is if you have a distribution and it has maybe like one peak here, comes back down, then it has like another peak over here. Right? So notice that there are two values that have that top frequency, this one and this one. So this here is an example of a bimodal distribution. And something like this would tell you where to concentrate your efforts on. You'd want to concentrate your efforts and figure out why is this happening. So a good example was that tiger example. Remember the initial tiger example I went over was most of the tigers had this low weight and then a few had a high weight. But what if you sampled the same tigers and the distribution came out like this and they were all the same age? Then you can start looking at this group separately. Why does this group have a low weight? And then this group here has a high weight. And then you could figure out maybe they're coming from different areas. Like, why are we getting this kind of distribution where that we have a bunch with a low weight and then a bunch with a high weight? Here we had just a bunch with a low weight and then a small number with a high weight. Here we have that same frequency in the low and the high. And so again, you could just start digging in a little bit more, figuring out why that is. And then if we relate this to the Starbucks example, where we were sampling the number of people at a Starbucks location at 9 a.m., we got this kind of distribution, which made sense because at 9 a.m., these Starbucks locations should have a higher number of people. But what if we got something like this at 9 a.m.? Why do these locations have a low number of people and why do these locations here have a high number of people? So first you would see, are these locations here in a more populated area with more traffic? And then what if you figured out, no, that they're both, let's say, in a downtown core where there's a lot of people for both of them? And then you could start digging in further. So maybe do these locations here have worse service, so people just don't want to go there? These ones have better service. It's tough to say. Maybe these ones are bigger in space. So maybe there's some people doing work in the morning. We don't know. But what the point I'm trying to get across, you can get something like this and you can start looking into both of these groups here a little bit more deeply and figuring out why you're getting that sort of shape. And then you can also have, you probably won't run into these, but you could also have multimodal distributions, and that's basically if there's more than two peaks. Or more than two modes. So there would be more than two of these kinds of spikes. And that's pretty much it for patterns of distributions for now. I'm actually going to be talking more about skewness when we talk about measures of central tendency, when we talk about mean, median, and mode, and how those get affected when you start getting distributions that are skewed, or if you have distributions that are symmetric.